The whole point of engineering is to plan, design, construct, maintain services. But in an informal settlement, that planning kind of goes out the window. The best stormwater management systems, as far as I'm concerned, are the ones that don't look like stormwater management systems. A big city like Cape Town running out of water is big news. In fact, particularly because it's Cape Town. What one realizes after a while is that the services have got to suit the people, not the people the services. But one of the good things about all of this thing, they say you should never waste a good disaster,
That is Neil Armitage, Emeritus Professor from the Faculty of Engineering and the Built Environment at the University of Cape Town, South Africa. Neil's illustrious research career has seen him move from river hydraulics to stormwater management, which led to his instrumental role in enhancing South Africa's knowledge and adoption of sustainable drainage systems. He is passionate about ensuring that stormwater management practices target quantity, quality, amenity, and biodiversity benefits, all while sharing his lifelong passion with students, family, and the world. My name is Peter Marcus Bach, and this is the Grand Challenges Podcast, a show about inspiring individuals who are stepping up to tackle the global challenges that our world is facing in their own unique ways. We reflect on the many out-of-the-box ways our guests have navigated the complexity and intricacies of the environment at the cutting edges of science, engineering, technology, and design. On today's show, Neil and I reflect upon his incredible journey from early engineering to river hydraulics, sanitation, and how he became a champion for stormwater management across South Africa, especially with sustainable drainage systems, his preferred term. We hear his experience with Cape Town's infamous Day Zero drought, discuss the principles of the engineering profession, and look back upon Neil's most important career lessons and his plans for the future. Detailed information is provided in the show notes over at petermbach.com/podcast. Thank you for joining us today, and please enjoy the show. Neil, it's good to have you here. Welcome to the show.
Oh, thank you very much for having me.
And we are sitting in, well, not really sunny Delft, but we've been getting the sun on occasion.
In between the rain.
But yeah, you're from Cape Town, well, originally from Zimbabwe, formerly Rhodesia, but you've been very instrumental in a lot of the stormwater, wastewater developments across the entire African continent, I could say.
I'm not sure about the African continent because it's a big continent, and I've mostly been involved in South Africa occasionally, but further afield. But yeah, South Africa maybe.
But I definitely saw your name when I was starting out my PhD and I was looking up all the different design guides for blue-green infrastructures or sustainable drainage systems. And well, I'm sure we'll get into terminology today. But yeah, looking forward to having you and hearing your story and your journey.
Oh, it's nice being here.
But I guess one lovely story that you told me, and I'm sorry you have to tell it again because it's just too good to not tell, is your adventure in an engineering project that you did, which was to build this canoe chute. I guess, could you tell the audience a bit about what this canoe chute is and I guess the whole story behind it?
Well, it was one of my last projects as a consultant before I went to academia. We were asked to design a removable weir for the Berg River near Cape Town. And the idea initially was that this was going to be a place for the rowing course for the putative Olympic Games in Cape Town, which never happened. Well, it was a silly thing because the reason why it had to be removable was because there was a requirement that we needed to flush the sediment out, and the government wouldn't allow us at that stage to dredge the sediment because you needed a mining license for that, and there was so-called ecological concerns about taking the sand out. So no one, either I knew it had ever designed a removable weir before, so I was given the task of designing one, so I did one. It was all built out of concrete panels that could be removed. I was nearly finished when the local canoe club asked me, well, could I put a canoe chute in the weir, because they wanted to have such a thing. It was at the beginning of the locally very famous Berg River Marathon course. They thought it'd be really cool for the canoeists to come and run the boats into the upstream small little lake, which we'd create up the river, over the canoe chute and further down the river. Well, this, of course, was last-minute stuff. I didn't know anything about canoe chutes, so I asked them to provide me a design. So they provided me with a design, and I then did my hydraulic engineering thing, and made sure that there was a bit of a dissipation pit underwater to dissipate the hydraulic jump so that you didn't damage the river downstream. It all looked fine. Anyway, we constructed the entire weir, canoe chute included. And then just before it was kind of officially handed over, a weekend, I took a friend of mine to test it out because he was a canoeist. I don't do canoe. I sail, I don't do canoes. Anyway, fortunately, it was a sunny day. There wasn't much flow. and he came down the river on his canoe, and it was this most extraordinary sight. The first thing is that the canoe chute was angled at about 30 degrees or something to the horizontal, so it was very steep.
Yeah, that's pretty steep.
And the canoe came over, and it was funny because he got to about the halfway point with the bow of his canoe just sticking out in the middle of the air. And then he rotated, and then he went down the canoe chute very fast, and then he disappeared.
Oh, no.
And to my absolute horror, the boat eventually came up, and then I couldn't see him, and he was buried in the hydraulic jump at the bottom of the canoe chute. I mean, afterwards I realized that this was an incredibly dangerous situation. You should never go anywhere near there. Fortunately, he had the presence of mind to swim sideways out of the jump. You've got basically two options: to go sideways, to go deep down and follow the flow out. Looking a bit shaken. This, of course, was not good news. And straight afterwards, the canoe chute got banned for canoeists going down over it. But I think to this day, the really good guys, the kind of Olympic hopefuls, surreptitiously do try it out, but they go down sideways so they don't get caught in the jump. And the canoe race that I mentioned, they do start above the canoe chute, but they will have to portage around. They have to take the canoe and go around. Now, this was part of a longer story about this weir, because having designed this thing to be removable and having had two disasters where floods wiped out first the left bank and then the right bank, and then ended up being a insurance case, I then applied for this job to come to academia at the University of Cape Town. And it was a long battle. I applied, and I was told actually I didn't have a hope because they were looking for a black candidate. It was shortly after the 1994 elections. Mm-hmm. But I persisted, and a year later, they contacted me. 1 year later, that's not bad. 1 year later, they'd contacted me and they said, well, they hadn't been able to find any black candidates, but I was in the short list of 3. Well, the short list of 3 was me. I had a master's degree, but no PhD at that stage. And 2 guys with PhDs, and one of them had extensive teaching experience. I had very little teaching experience. So basically, I was indisputably the weakest of the 3 candidates, I think, on paper. Mm-hmm. I think the only reason I was there was that one of the selection committee was the CEO of a consulting company, and he knew me from the workplace, of course, as one of his competitors. So I thought, well, what can I do to actually get past the guys with much more academic experience? The only thing I had was practical experience, but most consulting jobs are as boring as anything. So I thought, well, I've got nothing to lose. I might as well take a flyer. So I told them all about this weir and the canoe chute and how absolutely everything had gone wrong. And, of course, what we did to get it right. And, well, I don't know. I must have got something right because I got the job, much to the annoyance of the other 2. But the final irony of this whole situation is that they never did dismantle this canoe because they managed to get the license to dredge after all. So it was all my effort, this expensive removable weir with its canoe chute, was all in vain.
No.
Could have saved myself a lot of time and taken the standard design out of a manual of weirs.
All because they needed the detachable weir in the first place.
Yeah, all because they needed a detachable weir in the first place. And of course, the canoe chute, which was for these guys who were hoping to do something spectacular for the Berg River Marathon, and it's never used.
But it's one of a kind.
One of a kind, yeah.
And definitely got you to where you are now and really kick-started that journey that I think you're pretty much known for around the world, apart from a canoe chute.
Actually, one of the first things that I did at the university was I did some modeling in the laboratory as to how to design a canoe chute that would work. So I did, but sadly, I never got an opportunity to design another canoe chute. I think they decided to leave me alone.
But definitely an adventure in hydraulics. That's something you've really studied and taken to heart as your main practice when you pursued your higher education. You got your bachelor's in civil engineering and then went into hydraulics, hydraulic structures, river hydraulics. What was the motivation to go in that route?
Well, it's an interesting thing. You know, it's how do we end up where we end up? You know, at school, I didn't know what I wanted to do, as many of us don't. I was good at maths, physics, and chemistry, but I also enjoyed history, geography, and English. But I did realize early on that the maths, physics, and chemistry was likely to be a more lucrative route. I wanted to be a teacher, actually.
Oh, okay.
I wanted to be a school teacher, but then I realized school teachers are abused. They work very hard for very little money and do a lot of marking. So I thought, well, I can't do that. So then I went through the options, and the options in those days, if you were fairly academic, was, you know, you could do law, or you could do medicine, or you could do accounting, all of which sounded dreadful.
Numbers, repetitive.
So it ended up with engineering. And then engineering, there were 3 options in Rhodesia at the time. There was chemical, there was mechanical, and there was electrical. Well, I don't like fixing cars. I ruled out mechanical. Electricity was the most boring subject that I ever met at university. So ruled out electrical. So that was kind of left civil. And I didn't know much about civil except it involved bridges, which sounded quite romantic and sexy and all the rest of it. So
that seems to be the stereotype for the word civil engineering until you actually do it. Like then you see what it's actually about. You know, the traffic, the bridges, they're still pretty persistent. But water and geotech as well.
Well, water, I did know something about it. I didn't know much about it. And I sailed. And I still sail to this day. So we'll give it a bash. And it took me a while. I had to go and do military service in the meantime. But I ended up doing civil engineering at University of Natal in Durban. Mm-hmm. I enjoyed University of Natal, and I did okay in the civil engineering degree. But I was still completely uncertain. I found very quickly that I thoroughly disliked structures.
Okay.
And geotech, not much better. Most of the courses I did well on were the non-engineering courses.
Okay.
So the course I probably did best overall was economics. I guess in a different life, maybe I should have gone down that route. I don't know.
But it is still relevant, and many civil engineers sometimes forget the economic aspects, or I certainly can't estimate costs of things. I'm still learning as we go, but sometimes it's just, I don't know, how do you call it? Very esoteric to me.
So after my first year, I tried to change to chemical engineering, but that would have been very complicated. They didn't offer it back in Rhodesia as it then was. I would have had to have moved to South Africa. I wasn't intending to move to South Africa at that time, so I gave that up. But by the time I got to my final year, the one subject I really got to thoroughly enjoy was hydraulics. I had a brilliant, inspirational hydraulics lecturer, Professor Jeff Pegram, who's quite well known in stochastic rainfall and stuff like that. He's long retired now. So I enjoyed that. So I then thought, well, maybe I should shift to physics and do a master's in hydrodynamics or something like that, which, of course, is a silly thing because physicists don't do that sort of thing anymore. Maybe 200 years ago. So the head of the physics department very gently suggested maybe I should stay with civil engineering. I had a bursary commitment with now the Zimbabwean government because the Rhodesian government had been replaced. So I went back to Zimbabwe and I ended up constructing roads actually in rural Zimbabwe, main roads, which I didn't enjoy, but I certainly learned a lot. And then I ended up emigrating from Zimbabwe as the conditions became very difficult for everybody. I ended up in yet another civil war, so I decided it was time to leave, and I moved to join my family in Cape Town, where I had an offer of the consulting firm. I had, in fact, 2 offers. One was for roads and one was for water, so I guess one which I chose.
Well, since you love sailing, I guess your connection to water has been established since you started a long time ago.
So, yeah, I was in water. I was in a consulting company. It was mainly a structural company, which turned out to be a benefit because the water division was very small. There was initially 2 of us and the other guy left. So I got called into the big boss's office and asked, this is less than 3 years after graduation, and I was asked whether I could cope with all the different demands that would be placed on me if I was to stay in water, and I immediately said yes.
Well, why not take on the challenge?
And I did everything, actually. I was doing everything from general water supply, sewage, to coastal engineering, to wastewater treatment, to water treatment, to hydrology. I ended up doing a first-year graduate diploma which was focusing on wastewater treatment and coastal hydraulics, coastal engineering. And then I did a master's in coastal hydraulics. So I gained a lot of experience running a wide range of projects in civil and hydraulic engineering until, as I said, this advert came up. And it was at a time when I really thought that I needed to move. I'd gone as far as I was going to go with the company I was with. If I was going to I just needed a change, and it seemed like the perfect answer because it married my old interest in teaching with my sort of passion for hydraulic engineering. So I moved.
Solving a number of problems in the world.
But then when I got to university, of course, as you'll know, is that universities look for certain types of activities. It's not just about teaching, it's about research. You've got to have your PhD. So I then thought, well, I must register for my PhD. And of course, I wanted to do it in hydraulic engineering. So I found a supervisor at Stellenbosch University, a neighboring university, who was quite a renowned expert in rivers and sediment transport in rivers. So my PhD duty was in looking at local scouring in rivers, about river abutments and piers. But the problem was that I had now left a consulting job for a lower paying job in academia. My wife had left her job as a secretary initially to study further, but then her father was terminally ill, and then we had 1, 2, 3 babies in a row. So she was full-time mother.
Oh, that's
so suddenly and we had moved house to a more expensive house. So it was one of the perfect storms. Everything went wrong. So I had to get extra money. So my supervisor, my PhD supervisor, said, well, he's got this project that he needed help in. It was to do with sediment problems in rivers. But one of the aspects of it was the problem of removing trash and debris from stormwater systems.
Okay.
Which wasn't really his field. I don't know why it was included, but he thought I might be interested in it.
And that, as humble as it is, kind of blew up into what you do nowadays in South Africa with sustainable drainage systems.
It did. I mean, what happened was that something that was actually a consultancy became ultimately bigger than my PhD. So I went to Australia, looked at what they were doing. I did extensive testing as in the laboratory. And in the end, I wrote up a manual about how to design litter traps. And I published it quite widely, which was good because meantime, my real job, I thought, which was the modeling of local scour, I finished my PhD eventually, and I eventually managed to publish a paper, and I managed to even get some more money to look at the extent of the problem in South Africa. It was taking me absolutely nowhere. It's sort of frustrating thing. This was what I wanted to be a world expert in, and no one was interested. And my sideline, everybody was interested in. So it was very useful in many ways. The useful thing about it is that I'd done this thing in litter traps, but I mentioned a kind of a last line at the end that it would be much more sensible to stop the litter getting into the stormwater system in the first place, to try and move it out of the stormwater system when it's there. But that's essentially a people thing. It's a behavior thing. The Water Research Commission promptly came back to me and offered me quite a lot of money to actually continue and determine the extent of the problem, how much litter was getting into the system, as well as how one might engage with people to stop littering. Well, I wasn't quite sure about that because that would mean dealing with people, which engineers, of course, don't normally
Not always
do.
the best people.
Not always the best people. But I was given some very good advice. I was advised to go and see a chap called Professor Muggsy Spiegel, who was then head of the social anthropology department and had been extensively involved in lots of projects in formal settlements and rural settlements. Well, he initially thought, oh my goodness, here's another crazy engineer who's trying to engineer people. So it took a little while. But it started a kind of a collaboration that continued until way after he had retired, and in fact has continued in the form of one of his former protégés, who now still works with me, Amber Abrams. And it was also the start of diversifying out of kind of classical hydraulic engineering into more of a holistic, interdisciplinary approach to dealing with water problems in urban areas, where there's this sort of ongoing dynamic between the engineering and the people. So, you ultimately, of course, you provide these services. So you even call them services for people. Sometimes engineers just think that the people must just simply accept them and do work with them like you design them. What's wrong with the people? They're not using those services the way they're supposed to be. But in fact, what one realizes after a while is that the services have got to suit the people, not the people, the services.
That is true. And we are really seeing this now in sustainable water management or integrated urban water management, which I think is a very close term to you because you really brought that into South Africa, that it's really this holistic thinking. And we have to stop designing things like cookbooks. We need to be more place-based, something that blue-green infrastructures or sustainable drainage systems are very well versed with. And services, and not just, I guess, the infrastructural services, but now we're even thinking of ecosystem services as well.
Yes, indeed. So, from there I went into greywater management and informal settlements. Then I got caught for a while on the huge pull there is for dealing with the problem of sanitation in informal settlements. It's a massive worldwide problem. And it's in many ways an insoluble one because if you think about it, the whole point of engineering is to plan, design, construct, maintain services. But in an informal settlement, that planning kind of goes out the window. It's not that there's no planning, because obviously the people who are building their shacks will have some plan in their mind, but it's not integrated with the services. And then what tends to happen is that you end up in the position of trying to cope with a problem that shouldn't exist in the first place.
I guess it's highly decentralized. There's, I guess, a lot of unknowns in terms of what's there already, what can be done. And then I guess there's also, if you're trying to introduce a system, it kind of is new regardless of what infrastructure you choose to put into the informal settlement.
Well, we were looking at greywater. We were asked to look at greywater. In a formal settlement, it's when you have no formal sewerage, where do you put your wastewater? And I get quite annoyed. A lot of the world sort of bodies involved in this get this focus on dry sanitation as being the way forward. And they will trot out the story about how much water the flush toilets require, and this is a waste of water, which it is definitely, or can be. And the treatment costs and the costs of the pipelines and all the rest of it, and how we can do dry sanitation. And yes, of course you can, but there are two big problems with it. And the problem number one is that the people don't want it, because they will argue, well, why are we treated differently from the rich people, and why should poor people have dry sanitation? Wealthy people have flush toilets. So straight away, you've got a social tension there. But the second thing of all is that by far the largest proportion of the water in sewage is actually greywater, not in fact fecal matter or urine, whatsoever. In fact, what's happening is that you're using the greywater to hydrotransport your fecal matter to a centralized place where you can process it further. I mean, it's got you can argue a lot about centralization or decentralization, but the bottom line is that if you don't have sewers, what do you do with the greywater?
Yeah.
And we did quite a lot of work in greywater and how you can deal with it at a local informal settlement level. Again, ending up in a fairly pragmatic set of guidelines, which can only really remain, I think, emergency guidelines, because none of it is really ideal. It's fine if you're living in a remote rural area, but once you're in a high-density urban area, you struggle.
Your planning solution becomes completely different.
Or you end up actually with ongoing problems with politics, really. And it becomes the politics of the settlement. We're working with one group in an informal settlement, which was cooperating, and another group would sabotage what was happening. Because for various reasons, there's ongoing power struggles as people are fighting for access to resources. And in some instances where we tried to do a self-help scheme in one settlement, we were told blankly that please go away, because if we solve our problems, the government won't give us our free houses.
So disincentive.
So disincentives has got to do with the way South African politics has panned out. But I got a break out of it when I got in quick succession two large, by South African terms, projects from the Water Search Commission. One looking at alternative stormwater.
Okay.
And the next one was, I got alternative sanitation. Mm-hmm. And then the third one that came after it was, in fact, water-sensitive urban design.
Yet another term, which I think might be an interesting time for us to engage in a discussion that I engage with everyone before we revisit your preferences between wastewater and stormwater. But we've mentioned blue-green infrastructures, my preferred term. You've worked a lot with SuDS, so sustainable drainage systems. Actually, in a previous discussion, you corrected me. Sustainable urban drainage systems is now sustainable drainage systems. And now we've mentioned water-sensitive urban design. But what is your preferred term? And I know you have very strong opinions about this.
Well, I was in the fortunate position of being able to kind of choose a term for South Africa. This was already 15 years ago or so, where the common terms were BMPs,
Best Management Practices,
LIDs,
Low Impact Development,
WSUD,
Water Sensitive Urban Design,
and of course SuDS, with or without the urban component. But it just seemed to me that this was crazy. So best management practice of what? It sounded like a accounting package, best management of your company, buy this package and we'll solve your... It just, how it related to water was not at all clear. And the same thing went for low impact development, which to me looked like we're going to build bungalows instead of double-story houses. Because surely that would be low impact development. Water sensitive urban design, I understood a little bit better when it was explained to me by some of my Australian friends as water sensitive urban design. So urban design, of course, is a well-established professional field. Mm-hmm. So I guess the idea was that stormwater managers were then going to hand over everything to urban designers, which I thought was a dangerous thing. But but at least I kind of understood it, and at least it had water in it. So I stuck with the British / European term of SuDS because it had three useful words. It had sustainable, it had drainage, and it had system, which all three I thought were very useful. So it's a term that I've tended to stick with. Since then, of course, we've had an alphabetical soup of other terms which have come up.
That's a great way of putting it.
So, some that are I think, sensible, and some which I just think are academics trying to invent a new field for themselves or something like that. I certainly see that Americans have drifted towards stormwater control measures, and that again makes sense. I mean, to me, I prefer to keep things simple. I prefer to say what it is that you're working on. I think there's a lot less confusion that way. I wasn't one of the co-authors of the famous paper where they had all these different terms, but to my mind, I think that in some ways, they could have just saved themselves a lot of time by saying all of these things basically mean the same.
In short, long form, subtle nuances, but it comes back to different practices around the same concept, different solutions that have slightly different designs depending on where you are in the world.
It does, but, really, I think the different designs is just simply a local flavor. So some of the other ones, nature-based solutions, I kind of think I was a bit annoyed about that one too, because nature does many things apart from work with water. So it does seem too broad to be useful other than as a sort of catch-all term.
Although it is used in a broader context, I guess originating from the conservation side of things. So it does work with water to a certain extent, but it also includes those solutions that not necessarily have to do much with water. And it's focused around biodiversity.
Yeah, sure. I think it depends where the focus is. Is it stormwater just one component amongst many, which it really is, I guess?
Yeah.
Or are you focusing specifically on the stormwater component, in which case I'd prefer some mention of stormwater or urban drainage or something like that. I mean, the other ones, of course, are blue infrastructure, green infrastructure, blue-green infrastructure. Okay, well, fine. The blue-green infrastructure I can certainly live with. It kind of conveys a general idea of what we're trying to do. But it also, to me, also kind of loses the focus on the stormwater side because, well, lots of things are blue and not just water. So
yeah, that is so true.
So it becomes vague again. I think a lot of these terms, as I said, are just trying to create a PR exercise, trying to embed yourself in the public's consciousness. I guess the average politician doesn't get excited by stormwater control measures, but they might get excited by blue-green infrastructure or nature-based solutions, which I think may be more politically exciting or palatable or sellable.
Or sponge cities.
Or sponge cities.
In Switzerland and China.
Well, China, of course, started that one off, which I kind of thought was interesting, but of course immediately flashed through my head what happens if you are in Johannesburg and you're in karst country with sinkholes form if you try and put too much water into the ground, or you are on a rocky terrain where there is no infiltration. Look, I mean, I can create some infiltration through the depth of my control measure, but it's not exactly what they have. So I think the sponge cities is Again, it's a sort of a nice political type tool, and certainly I think a lot of researchers have made a good living out of working with sponge cities. But at the end of the day, I think that it misses some of the sort of more serious aspects about stormwater design. Or urban drainage is another one, but of course urban drainage would also include sewage and rivers as well. I think I've done a lot of work in sewage, as I said, but I got out of it because I actually found that the stormwater was far more interesting.
I was going to ask, because you've had that experience now in the sanitation field and the stormwater field, but I guess you are leaning towards stormwater.
Well, yes. I mean, obviously the stormwater. Then we got asked to do the water sensitive urban design. We ended up calling it water sensitive design.
Okay.
Again, because a lot of the things we were doing actually would work just as well in a rural area. I mean, one of the bizarre things about this is that many of the techniques that we're using are not at all new. They are techniques that were used 2,000 years ago. I remember when I first went to Pompeii, seeing somehow they managed their water there and thinking that some of the modern engineers would probably learn a lot by going to see how the Romans did it, because it's an integrated system. You can see how they do rainwater harvesting. They've got their sewage systems and they've got their drainage systems, and they do a lot of multifunctional type approach.
Which is a very important aspect nowadays when we look into the field of water-sensitive design. I guess you don't trust the urban design as much, hence why you might have dropped that.
Well, yes, I tried to influence the urban designers, but not always successfully. So, yes, we then moved very strongly into the water-sensitive design field for a while, of course, and my group, I'd created a research unit in urban water management, because that was the term that was doing the rounds at the time. You still hear it. I think it's a good, solid term because it describes what it is.
That one has stuck, definitely.
Yeah, so I got frustrated because the University of Cape Town had many folk working on water, but we were all working in different little silos. So I was doing mostly sanitation and stormwater with my colleagues, and then 2 doors down they were doing wastewater treatment, and across the way they were doing advanced biological treatment of acid mine drainage and chemical engineering. And so the guys in geography were doing climate change and how it was going to influence hydrology, and then the guys down in economics were doing nudge factors to change people's behavior with the use of water. I mean, the whole thing just seems so silly. We're supposed to be a university, and surely we should actually work together and bring a holistic approach to it. And the university fortuitously then put out a call for interdisciplinary research units. So I got together with a couple of my colleagues from some of the other disciplines, and we put in a bid to form a completely interdisciplinary water research institute. And we were successful, and so we founded the Future Water Research Institute at University of Cape Town. I see it's been stolen by somebody else in another university elsewhere subsequently. We didn't patent it, I guess. So there we go. And it's still
shared the love.
It still continues to this day.
Yeah.
But what happened is that, of course, people in the end work on what they feel most passionate about. And as I approached my official retirement, I then decided that I was going to focus most on all my attention on what I really enjoyed the most, which was sustainable drainage systems, and in particular trying to plug the gap between theory and practice.
Yeah, and there's so many places I could go from here, because in a way, we have you to thank that South Africa has that practice in place much more than it would have if you weren't there. You had those design guides that you brought in, but also, worked on a lot of projects in relation to that. But I guess coming back to the group that you formed, one very important role it would have had to play, especially in Cape Town, and also the whole water-sensitive design aspect, is drought-proofing cities. This more cyclic, integrated approach to water management, being sustainable, but also resilient to the challenges of climate change. And so we've covered droughts on the previous episode 8 with Megan Farrelly, where we talked about Melbourne's story. But Cape Town in itself also had a severe drought. And in fact, you had a name for the point at which, the drought was at its worst, which was day 0. So I guess maybe to summarize, it was a multi-year crisis. It was around 2015 to 2020, but it peaked around 2017, 2018. Tell me about the experience, because I guess you were there firsthand.
Yeah, it was. One of the interesting things was that we published our guidelines for water-sensitive design came out in 2014. Mm-hmm. So I did my usual thing of trying to take this around the country to meet up with local authorities and consultants to try and get them to change their view about how water is managed in the city towards making the city more water sensitive. And as with my SuDS, I was treated with a certain amount of contempt and derision. As obviously I'd spent far too long in this ivory tower. I'd lost contact with reality. And then this drought started off in 2015, actually. And it was an interesting thing because I was at the last meeting of the Western Cape Water Supply System group, which was all the main actors, Department of Water Sanitation and the cities and the farmers and all the rest of it, about looking forward to see how the water supply system in the Western Cape was going to manage for the next couple of years and new projects. And then the drought hit. And basically what happened is we had 3 very dry years in a row, 3 of the driest years on record in a row. So very dry year, very dry year, very dry year. I'm not sure I always believe these calculations because it's all based on a non-changing climate, of course. And climate is changing, so you can't always rely on it, but it came out as something in excess of a 500-year drought.
Oh, wow.
And, of course, in the first year, people just said it was a dry year. And in the second year, people were saying, well, this is like 2 dry years.
Yeah, bad luck.
So it was when we had so there was the failure of the rains in 2015, the failure of the rains in 2016, and then the failure of the rains in 2017. And suddenly things were looking quite grim. The city itself had been progressively doing its water demand management thing, mainly by putting the price up. But now, when suddenly at the beginning of 2018, there became the very real possibility that the reservoirs were going to run dry before the rains of 2018. And we didn't at that stage know how good they were going to be.
Yep.
And panic set in. And the problem is, this, of course, a big city like Cape Town, which was over 4 million people at the time, running out of water is big news. In fact, particularly because it's Cape Town.
Yep.
It's an iconic city. It's known all over the world. Probably in South Africa, it's also run by a different party to the National Party. A lot of animosity between the parties. So, suddenly it became a huge political thing. And the politicians went into panic mode as they tried to control the narrative, both for good and for bad. We weren't actually that involved. One of my colleagues was asked to come and he got involved in some of the sort of dealing with the public and public perception. I mean, they did some interesting things. I mean, one of the things they did, which I thought quite brave of them, is they published a GIS of the city basically indicating who was meeting the water demand management targets and who wasn't.
Oh, wow. Okay.
So you could actually look up and find out which of your neighbors were using too much water. So,
oh, wow. Almost like calling out people. En masse at the city scale.
I mean, it was posed as, rewarding those that are doing a good job. But of course, the reverse side of that is you can see, why has my neighbor not got a flag as doing a good job here?
Oh, boy.
So there were, of course, potential threats of legal action. And there were other things as well. I won't go into them. But the interesting thing of all was that, of course, all the news outlets around the world were flocking to Cape Town to find out what was going on. And we weren't gagged because we weren't part of the team and we were the university. So we were inundated with requests for interviews as to what was going on. I mean, I got off lightly. I think I was interviewed about 20 times in the space of about 2 months.
Lightly.
3 in one day, I might tell you. I mean, I was interviewed by the BBC and Al Jazeera and some of these others. One of my colleagues, I mean, he was handling more like 20 a week, Oh,
jeez.
So, and of course, it was also very interesting because these news outlets, you could divide them into 2. There was one that was looking for the sensational story, who messed up.
Oh.
Who caused the drought? I mean, I was actually asked that a couple of times. And of course, I had my flip answer immediately. It didn't rain.
I guess that's the most obvious but safest answer as well.
I mean, who caused it? I mean, who are you going to blame? Are you going to blame God? Are you going to blame the municipal authorities? Who caused it? Look, it didn't rain.
Yeah.
So we're trying to react to a situation. People, and then of course there was the serious outlets, like BBC or whatever, who kind of really wanted to understand what was going on. But one of the good things about all of this thing, they say you should never waste a good disaster.
Yeah.
So is that all of a sudden, everybody wanted to know about water-sensitive design. How do you do this?
It's like, I guess, flood researchers, they celebrate when there are floods because they have data to analyze. And the drought researchers celebrate when there are droughts. I certainly felt that when I was doing my PhD. I thought, I'm doing stormwater harvesting and modeling of SuDS for that. And I think after the floods broke, everyone was interested in that. So yeah, don't waste a good disaster.
You mentioned stormwater harvesting. In fact, I couldn't get any funding for stormwater research in the drought, as you could well imagine, because all the money was going into alternative sources of water. So I thought to myself, okay, I need an alternative source of water that involves stormwater. Stormwater harvesting will do. So I managed to get a very nice grant on stormwater harvesting
during
in the middle of the drought.
I mean, let's contrast it. I mean, in Melbourne's case, more water fell on the city than it did in the reservoirs. Mm-hmm. So there was a good reason for it. But you're saying in Cape Town, you literally had no rain. So the actual amounts were very, very low, if not near zero.
Very dry. I mean, there was very little rain fell at all. So look, I mean, the one thing, it's interesting to see human nature as well. Everybody who could afford it, and I did it as well, but more for the scientific purpose of understanding it, bought rainwater tanks.
Oh, yeah.
Now, of course, the silly thing about rainwater tanks is they're absolutely useless in a drought because they don't hold enough water.
That's true. You can't bridge.
You can't bridge. So a rainwater tank is very useful if it's a case of having some cheap water available for a couple of dry days between storms. It's not going to get you through a 3-year drought. It's not even going to get you through the week.
No, certainly not.
But people were buying rainwater tanks. So I'd already done with another PhD student. We looked at rainwater harvesting as an option and decided that rainwater harvesting is not actually a very good or cost-effective way of increasing water supply. Neither is it a particularly effective way of stopping flooding. You just don't have the volume and storage to make a difference. But stormwater harvesting had possibilities. So stormwater harvesting became a thing, and I had a PhD student, John Akedi, you'll know him well, where we looked at how you would do this in terms of real-time control on repurposed ponds.
Yep.
Alternatively, by trying to do managed aquifer recharge and recovery in the aquifer in Cape Town, which has kind of been a very good base for where I am now, which is how would you actually repurpose those ponds?
And I guess it's working with what's already in place as well. So in a way, retrofitting or upgrading the landscape to suit the needs. What are some of the key contrasts between South Africa and maybe other places you've been to? I mean, you spent some time in Australia and you've also worked in Brazil as well around water-sensitive design.
Yeah, look, I've been to Australia many times and Brazil a couple of times. And of course, Europe, I've long since lost count. I think the big thing in Africa, and it would be more than Africa, but certainly in Africa, is the poverty aspect, is the fact that South Africa has incredibly high unemployment and a very extreme difference between rich and poor. There's inequality and poverty are serious challenges that have got worse in recent years, not better, sadly. It does make working in many areas very challenging. So we're currently working in a low-ish area. It's not informal settlement, it's formal, but it is the poorer part of town. And, one of the things you learn very quickly is that you have to put an enormous amount of time into engaging with residents.
The human factor.
The human factor. Yeah. So, in fact, it's dangerous if you don't actually have some sort of agreement with them to work in that area. And when you do something, you have to be very careful to show them the direct benefit they're getting from it. And this cannot be kind of long-term, wishy-washy type benefits, it's going to be nice and green. They want to know straight up is there money in this thing?
Yeah.
So a lot of the designs that I've done for all my career, in fact, but particularly now, are focused heavily on labor-based and using local labor, unskilled labor. You do simple things. If necessary, you run a little hour or two workshop on how you do things. And you try and keep things as simple as possible, using as much local material as possible. You're particularly concerned about the very real threat of not only violence, but vandalism and theft and all the rest of it. So try and avoid materials that have a resale value. So we did a lot of stuff out of sandbags. And the sandbags themselves were made out of recycled plastic, which I'm kind of ambivalent about because I get worried about putting plastic into the environment in any form or shape whatsoever. But nevertheless, it is at least recycled, and then we planted grass over the top. So maybe we've buried it in 400 years or so. And try and use local labor. Even when we put in a measuring weir, we ended up building a concrete measuring weir, but again using local labor to dig and to mix the concrete and to pour into. And one of the nice things about that is that the people that do that become quite excited about the project. They become engaged in the project, and you get a form of citizen science. So I think it was yesterday I was sitting in one of the talks, and then suddenly along comes this WhatsApp. The municipality has come there with their tractor, they're cutting the vegetation. But of course, we've now created this biodiversity area, and we've created this infiltration area, and frogs have come back into the area, and we're getting butterflies and all the rest of it. So panic sets in because we don't want this over-enthusiastic municipal worker to kind of mow down all our vegetation that we've tried so lovingly to reinstate. I think disaster was averted at the end, but to me, the beautiful thing about it is that residents will tell us when there's something going on. We haven't quite got them to the stage where they take full ownership. We're trying to set up these social compacts. So the city has a mechanism by which if you can put together a group, I'm not sure how many people, 10 or so, elect a chairman and a treasurer and a bank account and all the rest of it, and they will give you small amounts of money to maintain city assets, essentially.
True.
They're called Friends of, get Friends of the Least Big River, Friends of the Common. Yeah. There's a model, I think, that's used worldwide.
True. I've seen it in Australia. I've seen it in, can't remember what other country at this stage, but yeah.
They can work very well. One of the problems with them, though, is that it's much easier to work with professional people who are accustomed to taking responsibility and driving situations.
But also to avoid things going wrong, like the mowing, accidental mowing, which you've luckily averted. But I know in Australia, maintenance of systems as well sometimes results in these kinds of outcomes where it just doesn't work anymore because someone made the judgment call that it looks ugly or something.
But, what we're trying to do is get them to form a compact because they can do their own mowing. Yeah. They can do their own pruning. They can do their own weeding. They're taking out the litter, all the rest of it, and can provide jobs. But it is interesting, the kind of issues that we get engaged in, and they seem so mundane. Person X hates person Y. They will not work with person Y. Person Y will not work with person X. But actually, we need person X and Y to be both involved. Otherwise, there's going to be trouble.
Yeah.
So, what from an engineering point of view is quite simple. Arrange 10 people in a committee and get the city to give them some money to do the maintenance. We'll tell them what to do. Really simple. Turns out to be an exercise in politics as you're trying to stop people killing each other.
And politics and institutional challenges are often, I guess, partly motivated by historical siloing of different responsibilities, but also, interpersonal issues that, I guess, through stewardship, through joint construction and involvement, you might be able to smoothen out.
Well, it's interesting. I mean, human beings seem to find every conceivable way to dislike other people. Yeah. I mean, it's quite sad and extraordinary. But, one of the things that has kind of really surprised me in my career, which came out most poignantly when I was doing the alternative sanitation, is that, I had this partnership with a social anthropologist. And, when I started out, I gaily assumed that it was going to be like a 50-50 partnership. It was 50% technical and 50% social. And it didn't take me long to realize I was completely deluded. It was a maximum 10% technical and 90% social.
We've heard it all too often on the show before. People often say it's, we have the technical solutions, but we don't have the institutional capabilities or economic aspects. Listeners, if you want to hear either example, you can also go back to episode 16 with Matt Santamuris, who mentions that from an economic standpoint, or episode 22 with Françoise Bichat, who basically gave us that beautiful quote of us having godlike technologies, but medieval institutions and Paleolithic emotions.
I think that just about summarizes it.
Yeah, no, that's very true. But I guess if you had to summarize SuDS, or the concept of water-sensitive design, you teach it really in terms of the four fundamental things, which is quantity, quality, amenity, biodiversity.
Absolutely. So I do this in fact, I do 5 often because the water quantity thing can so often be a flow management. Mm-hmm. And I try to point out that it's also a water resource as well. We talked about stormwater harvesting. So I think it's not always about trying to get rid of the water, which I think a lot of old stormwater management was about. It's also about seeing it as a resource in of itself. Mm-hmm. So the first one really can be subdivided. But yeah, sure, it rolls off very quickly in quantity, quality, amenity, biodiversity.
Yeah, true.
So it's kind of catchy, and at least if we can get engineers and planners and architects and all the rest of it to think that way, it helps. Talking of architects, in fact, some while back, decided that actually engineers are too difficult to work with. They're too stuck in their ways. But I got a very sympathetic hearing with the landscape architects, which kind of got me thinking. Now, one of the things is that growing up in Rhodesia, back in the sort of, semi-colonial era, I guess it was, we all had SuDS automatically already because no one would dream of putting pipes in the ground unnecessarily. We had pipes for water supply, but we had on-site sanitation systems. We had flush toilets, but we had septic tanks and soakaways.
Yep.
And all the stormwater drainage was done through what we would now call swales. So I was quite shattered when I heard that people actually put all these things in concrete pipes. And I guess it makes sense in 19th century London where the problem was horse manure, but it doesn't make a lot of sense in many other cities. Our space obviously is a challenge in many areas. But it kind of occurred to me that actually a stormwater engineer's greatest ally quite conceivably be landscape architects. They're often very abused in the sort of professional pecking chain. The main architect will design the structure, and if you're lucky, someone says we need some landscaping, and then comes a landscape architect. But in fact, most stormwater can be done by clever landscaping. And so I ended up forming an alliance with landscape architects. We have them in the team and we talk a lot to them. And I've tried very hard to kind of empower them to realize that they have an important role in stormwater management and that the best stormwater management systems, as far as I'm concerned, are the ones that don't look like stormwater management systems. They just look like clever landscaping.
Water sensitive and integrated into the urban design.
Absolutely.
But you still haven't told me why urban designers are dangerous, or at least planners, from what I understand.
Well, planners, the biggest problem I've had with planners is that for some unknown reason, a lot of planners don't seem to have understood anything about gravity. So as I continually tell my students, they obviously don't laugh at my jokes anymore, but is that gravity sucks.
True.
Which, of course, is deliberately meant to mean that it also can hurt you too. But water goes downhill. And I had quite an introduction to how poorly understood this concept is when I actually worked with a bunch of mainly engineers, but also planners that were selected from around the world on scholarships, Bill and Melinda Gates scholarships, to attend an advanced course in sanitation at IHE Delft, as it is now is, and kind of suddenly realized that they couldn't actually show me on a plan where the water was going to go. And then I found to my horror that many of my own students couldn't do so either. I mean, it's an interesting exercise. I mean, obviously, most stormwater engineers wouldn't even think twice about it. But the fact of the matter is, obviously it's going to go perpendicular to the contours until it meets an obstacle, and then it's going to follow the line of least resistance. So, you should be able to draw on a map, a contour plan, exactly where every drop of water should theoretically end up. And that, of course, is going to determine how you lay out the design of your city. But the reality is, and I used to get my third-year students to go and redesign the stormwater systems in neighboring suburbs, is they would come back to me and they said, hey, Prof, this is quite weird. We've got this steep road, ends up in a cul-de-sac. Or it ends up in a T-junction. And I say, yes, I know. In fact, every time it rains, this guy's garage gets flooded because the water just keeps going down the hill. I mean, no one told the water that you had to stop at the stop street and turn right. I mean, it just keeps going. Or alternatively, one of the first things I came across when I first came to Cape Town, there was a flood in one of the suburbs. And I found there were little lakes in between the intersections because some person had designed the low point in between the intersections. So when it rained, it all collected in this bowl in between the intersections. And they would have a catch pit which would take it to the stormwater system. But at the very best, the stormwater system is designed for the 2-year flood or whatever it was, and they just had the 20-year flood. So, of course, the pipes wouldn't have been able to handle it in any case. But the other thing which I found astonishing was that it never occurred to anybody that all the plastic bags and branches and what have you, would also flow to the low point and plug up the catch pits, absolutely blocking them. So no water would get into the conduits at all. So after that point, I used to make a point of making them track where this water is going to go and make sure that you align everything with it. Your road alignment should be done in such a way that you're going to convey the water safely through your development. In fact, to me, it's the most important thing that you need to do when you're doing flood management.
Oh, certainly.
You've actually got to ask yourself, what would happen if there was the worst storm in record was to happen? I'd abandoned this idea of designing for 50 and 100-year floods. I used to get my students to design for the regional maximum flood, the worst possible flood that you've got. You need to make sure that it's survivable. It will do a lot of damage. You can't help that. No. But it needs to be survivable. It needs to be able to flush through your development and out. And, astonishingly enough, architects, urban designers, town planners, and many engineers don't seem to get that. They get the idea that a little pipe in the ground with a little opening that's going to clog, of course, is going to solve all their problems, and it doesn't. And the problem is because it does it for, let's say, 9 years and 364 days in a 10-year period, it looks okay until the day arrives.
Until that one event washes everything away.
Until that one event comes and exposes them for the foolishness of the thinking.
Which can only get worse nowadays with climate change as we're going to get more extremes.
Absolutely. Yeah. And of course, it's very difficult to know what to do once the damage has been done.
Of course. Yeah, that's why we try to bring these disciplines together and teach them that gravity indeed sucks. But you can work with it.
You can work with it.
No, definitely. And so now you're semi-retired, but you're still pretty active in water-sensitive design, or SuDS, giving me a weird stare. So what's in store?
Well, that's a good question. My passion still remains of trying to get SuDS embedded into the psyche of planners and engineers in South Africa. In particular, of course, if I can impact the rest of the continent and further afield, that would be wonderful. And I fortunately have students who've gone outside South Africa, so hopefully they're carrying on the good work. But it is really about trying to understand what it is that's stopping its implementation, but also to stop the poor practices that I'm seeing. So, for example, in permanent locking concrete pavement, PICP, it was very early adopted as the solution to dealing with stormwater in particularly these gated villages, which are very popular in South Africa because we've got a security problem. So people are huddling together in, term prisons really, because they're surrounded by high fences and electric fences, and there's gates and all the rest of it. And developers don't want to give a single square meter to a pond or anything like that might provide a better solution. So they got into doing PICP, but the problem was that nobody actually knew how to do PICP, or very few people knew how to do PICP. So it was done badly. And I very quickly realized that most of the PICP I was seeing had already failed within 1 or 2 months after construction.
Yeah, that's not very long.
Which is totally unacceptable. I mean, 20 years might be okay, but 2 months is definitely not okay. So I then got into a series of research which ended up with me last year producing these guidelines on the design, construction and maintenance of PICP. But there was only one element of many, because now we're looking at established cities which are not water sensitive. They've got largely conventional systems that are having major impacts on beaches and estuaries, potentially threatening economic viability of these areas. People come to Cape Town for our beautiful beaches, but you're not going to go on a beautiful beach that's covered with debris or plastic bags or algae or something like that, or swim in water that's brown because of the algal blooms, which we do get. And Durban's had a lot of problems with this thing as well. So how do you retrofit SuDS within the city? So I had a series of students look at various catchments in South Africa, feeding into sensitive estuaries to try and see if we could model that. And I very quickly realized that as an international group, I think, have particularly useful modeling tools to model the impact of SuDS at scale. We have many, many, many tools to model individual SuDS elements. But these are not terribly helpful when you're working at a scale of 20, 30, 50 square kilometers. I mean, Cape Town itself is vast. It's about 2,400 square kilometers. I mean, it's no use you telling me that this tiny little bioretention cell is doing a good job, because in the context of Cape Town, it's not doing a job at all.
And let's just face it, I mean, terminology-wise, water-sensitive urban design is focused on multiple systems. The terminology for SuDS, sustainable drainage systems, is plural. And a sponge city, we're talking, citywide. The actual philosophy behind it is that we're trying to manage runoff across the city.
So you start looking at tools, and the tool that I've chose to work with is swim-based, specifically PC Swim.
Very famous stormwater management model.
Which I helped to get into South Africa through a friendship I had with its developer, Bill James. So it's a tool that many stormwater engineers in South Africa are familiar with.
Yeah.
And there's many things one can criticize about it. It's very simplistic in many ways.
But it's versatile.
And it's free. At least the basic engine is free. And free is very important in a poor country. We're not going to go buy expensive software. And of course, the biggest expense of all is training people to use it.
Mm-hmm.
So I then started to look and see, well, could we not use PC Swim for water quality? And water quality, it has LID tools in it, which I suppose suggests some sort of water quality aspect, but actually it doesn't really do quality. It actually deals quantity. But of course, there's a pollutant content with the water itself. And it doesn't at all deal with the larger scale things like ponds. But it does allow you to write little routines into it.
That's convenient.
That will allow it to do something about the water quality in a form of concentration. So it deals with pollutant concentrations. So we then started looking at, well, what does this mean? It has a way of doing build-up and wash-off modeling, but I don't know where we would start in a big urban catchment in South Africa. Whatever. I'm sure that whatever we do there, it would be fanciful because we just don't have the data. So constant EMCs, event mean concentrations, seemed to be as good a way to go as any other. We could get data from the literature and we could compare it against the quite long database we have from the city and grab samples that they take at various points and adjust the figures so that they kind of matched what we were measuring. So it's basically a calibration of the constant EMCs. And then we looked at data to see how, when anybody had got ideas in pond performance, particularly against hydraulic retention time, it had already become obvious that it doesn't make any sense to put in a pond where the water flows in one side and out the other side a few minutes later. No processes are going to take place in that. One of the downsides of SuDS is that a lot of the processes take days, if not weeks.
Usually necessary for the removal to happen. Yeah.
For the removal to happen. Whatever process. I mean, there are obviously multiple processes going on. And in a sense, you don't need to know that to be able to model it. I said right from the beginning, I initially did my graduate diploma in wastewater treatment. And in wastewater treatment, I was fully aware of how you design maturation ponds on a very simple linear model or first order decay model for things like E. coli. So I thought, well, why can't we do this for ponds? So we did a bit of this. And of course, as one happens when you start doing this, is you start finding out all the gaps. Mm-hmm. I don't actually have these first-order decay models for South Africa. I don't really have really good EMC wash-ups for different land uses. And so that has become a bit of a passion for me. Can't we at least provide engineers in South Africa with a very simple model that would allow them to at least get a first-order assessment of how much impact various interventions are likely to have. Of course, what we've discovered so far is they don't always solve all your problems. You actually need to do a lot of SuDS before you actually get a significant benefit. And it's also a law of diminishing returns. No matter how many SuDS you've got, you still have some sort of residual that's going to come through. So that's the one side of it. That's the theoretical side of it. And the practical side, which I'm still working with, is okay. So if you're going to start making better use of existing infrastructure, because of course you're confined with space. So if it's like a detention pond, how would you do it? And as I said, a lot of it becomes an exercise in dealing with residents as you try to configure abandoned detention ponds into multi-purpose, multifunctional infiltration ponds that are doing all these good things of quantity, quality, amenity, and biodiversity, which in fact we have shown can be achieved.
Yep.
But it is, at the moment, it's kind of still at a more or less pilot stage, if you like, or exploratory stage. And my biggest fear in life is that if I just simply pack it in and go and play bridge or go sailing or do all these other things, those consultants out there will quickly forget I ever existed. And I won't see the kind of transformation of the city I was hoping to see.
But that passion and the legacy you've built up to this point, I think, has created tremendous impact, not just in South Africa, but across the world. And
We're very kind.
I think the amount of community engagement also in the urban drainage community that you do, I think will definitely ensure that a lot of that remains in the back of our heads, especially the young, and they can take on the world, take on the new challenges with it. So I certainly think there's a lot there, and I'm extremely excited to have been able to talk to you today. Just like every other guest, I'd love to ask you a few questions that I ask all my guests so that listeners can then learn a lot more about you. And I guess, the inspiration, we've heard a lot about that. But what is that day-to-day element now that drives you? There's so many elements, but what is the one inspiration that drives you now?
Trying to make a difference.
Yeah. And I guess in practice, especially bringing knowledge in.
I mean, I came from a consulting background. I was a consultant for 11 years. It's an interesting thing. There's a sense in which I always felt a bit of a fraud, actually, as an academic. The teaching was easy. Teaching was what I originally wanted to do. And it also appealed to my performer side. I did a lot of performance, actually, as a young person. Initially, it was quite a lot of acting, but I discovered after a while I'm not a particularly good actor.
Okay.
So I got out of that, but I used to do a lot of singing.
Oh.
And I like it from the performance aspect. Now, I don't do much singing these days, but what I really love is a stage to talk to students. And I just love working with the students. I love getting them worked up and excited. That aspect has always been, for me, the greatest. And, it was interesting, when I finished up officially at the end of last year at the University of Cape Town, I was offered 2 contracts. One was for the ongoing research, which I was pleased, obviously, because it was my baby. I thought of this. Yeah. It's something I'm trying to do. So, of course, I'm passionate about it. But in many ways, I was also just as passionate about being asked to come back and teach the 3rd year's hydraulic engineering. It seems so mundane, but I love it. I absolutely love it. I love the sort of dynamics of the classroom. So that's been really great. I did it this year. I'm hopefully going to do it again next year, probably for the last time, sadly. But there's still postgraduate stuff. So
there's always opportunities.
There's always opportunities, and maybe even putting together some seminars on SuDS design. I'm thinking at the back of my mind that I might do that and see if I can kickstart some of my colleagues into doing a better SuDS design than is currently being done. If I can do that, that would be fantastic.
Certainly, it would be great to keep the activities up. I enjoy teaching, and I find students nowadays are so curious. They ask plenty of questions. They love to interrupt you, and they really make you then think and enter a discussion with them. That's been my experience for the last few years in my own teaching. So was there a key moment or book or event or person that completely changed the course of your career or mindset?
I mean, there have probably been quite a few, but there was...
the Canoe Chute.
The Canoe Chute, yeah. No, the Canoe Chute itself was something I was quite embarrassed about to this day, actually. But, nevertheless, it was useful. But actually, there was probably one key moment. It was about 10 years into my career. Remember, I said that I'd been involved in trying to make a name in the modeling of local scour and rivers and was really struggling. And then at the same time, I had this sideline of dealing with trash and stormwater and how do you get it out and how do you stop it getting in. And really not at all as sexy, if I can say that, as the sort of the 3D CFD modeling and all the rest of the high-powered stuff that goes with the...
Detailed, but sometimes a bit too much in terms of numbers and equations, from my opinion at least.
And anyway, I, as I said, I had got involved with Bill James. I'd met him at a conference in London, actually. And then we went to another conference, quite by chance, in Adelaide. At Stormwater conferences. And then he'd come to South Africa. He'd offered his PC swim course. And then we'd ended up a year or two later meeting in Coastal Bush Gardens in Cape Town, which are one of the world's greatest botanical gardens. They're absolutely magnificent. Anyone goes to Cape Town, you just have to go there. You'll be absolutely blown away. Probably more species of plants there than any other botanical gardens anywhere in the world, because Cape Town itself has more species of plants unique to that area than probably the whole of Europe.
Oh, wow.
So it's absolutely amazing. We were sitting at the restaurant down the bottom having tea and coffee or whatever. And I was bemoaning the fact that I was feeling quite stressed out. I was, trying to do all these things. But most particularly, I was trying to balance this desire to make a name in hydraulic engineering through the local scour thing, as well as the sort of sideline that I had in urban drainage. And he kind of looked at me and he said, drop the local scour. Focus on urban drainage. There's plenty of hydraulics in urban drainage. The impact that you're going to make in urban drainage will far outweigh any impact that you might make in scour. You'll save yourself a lot of stress and time and trouble. You'll be able to focus much better. Well, I mean, now in retrospect, of course, it was obvious advice. I mean, it was something, of course, it is the answer. But sometimes you need somebody to just, older and wiser, who's been there, done that, he's had a good career, he's made a name for himself, just simply tell you, drop this,
Focus on that. Yeah.
And you'll be much the better for it. And I took his advice. I did exactly that. And it was brilliant advice.
A big moment of revelation.
Big moment of revelation. And from then on, urban drainage was my thing. And I stuck with it ever since. I got more involved in conferences like ICUD. Yeah. I got on the JSUD, Joint Committee of Urban Drainage, which then brought me into contact with experts around the world. I shamelessly copied a lot of their stuff. I really owe pretty much everything to my very clever colleagues on JSUD and further afield who've given me amazing ideas. They've been examiners to my students. They've given me good advice, and I'm very grateful to it. It made my career.
Yeah. No, it's an amazing story, and it's an amazing moment of realization that really opened up a lot of doors to where you are. And so if you had a magic wand and you could change something about the world we're currently in, what would you change and why?
The world, my goodness.
Well, it could be the world, it could be about where you are, the practice, what you're observing.
Well, in the world, I think it really would be for people to stop fighting and start working together, because I really think that collaboration is the way forward. Of course, people are very different and got very different backgrounds and many reasons why they're angry. Yeah. But ultimately, progress is only made if we actually work together, whether we like each other or not. Yeah. So at a world level, at urban drainage, I think that long live SuDS, I think, and what a sense of design. I mean, there are places where it's not easy or appropriate to apply. I think one must be sensible about it as well. Yeah. One of my students used to talk about the ultimate objective of SuDS was to ban the pipe, which was a useful catchphrase for a while, but of course it's not true.
It shouldn't be one or the other. I think there's a balance.
There's a balance, obviously.
But hey, we have a new term, water sensitive and sensible design.
Yeah, water sensitive and sensible design.
WSSD.
There we go. Maybe we will make that our new research catchphrase.
We should write a paper.
Do that too.
So what tips and strategies can you offer in terms of time management? How do you maintain a balance between your professional and personal time?
I'm not sure I've done a very good balance, actually. For a long time, when I went to academia, I really struggled. In fact, I realized that I've been completely deluded. When I went to academia, I had this romantic notions of contemplation and scholarship and all the rest of it. And I actually found I ended up working twice as hard as I ever did in consulting.
Oh, wow.
And partly there was also a situation as well, but I didn't have a PhD. I had to work on my PhD. I didn't have enough money, so I had to do consulting. I did this contract research. And, I also had a very heavy teaching load. When I arrived, I was the only lecturer in hydraulics in the entire university. Wow. Everything with hydraulics was mine. So I had to do everything, and I was having to do it from scratch. So those first 6 years, I didn't take any holidays, any weekends, any leave. It was all devoted to trying to manage. When I started, my wife had stopped working, as I said. We had one child, and then another one appeared, and then another one appeared. And so I really think that I overworked, and I paid the price in many ways. My dad dropped down dead of a heart attack just around the time I finished my PhD, no warning. I went to the doctor. He did an ECG, and he went white. Now, it's always a bit of a problem when your doctor goes white when he's doing a checkout.
Mm-hmm.
It turned out that I had severe atrial fibrillation, so my heart wasn't beating properly.
Oh, no.
And the long and short of it is I ended up with a pacemaker.
Okay.
Which has worked brilliantly until now. Of course, I've had to modify slightly my activities, but it's been a lifesaver. But it certainly, it's probably genetic, but I suspect it was also maybe advanced because of just the stress of not showing where we'll be able to pay our bills, of trying to manage everything. And certainly for many years afterwards, I really found it quite difficult. I kept on getting extra responsibilities. So I got my PhD. Suddenly I was undergraduate convener. I was deputy head of department. I was head of department. I was deputy dean. I was all of these things. Everyone putting an additional burden on me. So I don't think I'm a good person to talk about time management, because I actually don't think I managed my time particularly well for most of my career. I think a lot of it was circumstantial. I don't blame anybody for it. I think if I blame anyone, it's myself. For too long, I tried to do the scour research at the same time as the stormwater stuff. It's a pity I didn't do the stormwater stuff from the get-go. My PhD should have been that research I did into litter management. I mean, it's interesting. If you look at my most cited paper, it's one of the first papers I did on trash. I think it took me 10 years to get one citation for the work I did on my PhD. I mean, it's it's weird. But, life happens, and I think you've got to deal with life as best you can. So my only advice in time management is that you need to manage it. I didn't do it particularly well. At least I did spend time with my kids as much as I could. I worked at home. I never missed one of my son's sports matches.
Oh, that's lovely.
And I think that in itself is a reward. The fact that he's very quick to invite me to come to things with him, I think is a testament to the relationship we developed. And I think, when you get to the end of your career and you realize that the family actually turns out to be the most important. So whatever you do, you need to prioritize family. I did to an extent. And I think the fact that I've got a good relationship with my kids is one of the greatest blessings that I have in life. I shall no doubt spend a lot more time with my grandchildren than I did with my children. I've got 4 now. But yeah, I think that's very important that one prioritizes, particularly your family and also hobbies as well. I kept up with some of my hobbies. I kept up with the sailing. I played contract bridge. But, there were other hobbies that I lost along the way, which is sad.
I guess sometimes for lack of time, but other times also, interest and changing interests. Certainly from my side, I think I've had many hobbies in the past which I don't pursue anymore, and there's always an opportunity to rediscover them. I certainly am doing that slowly.
It is, but sometimes these things go. I mean, I did a lot of singing when I was younger. I mean, I've sung opera in Opera House. I've sung 4-part harmony in the City Hall.
Wow.
I've been a soloist in the cathedral. I've done recordings. I've done lots of things. But there came a time towards the end of my PhD where I wasn't coping. I had to give up something. So the thing that I gave up was the singing. The problem is 20-something years later, it's not something you can easily get back into. I mean, I can do it.
You can change genre. I think you have that nice, how do you call it, Ray Charles voice? No,
but it's like a sport, In your 20s and 30s, one might be good at a sport. And then if you get out of it, you suddenly realize a few years later that you're just not at the standard that you were there. And then you get frustrated because you know that I used to be a lot better than this. Maybe I should just keep quiet. And
I'm certainly feeling this with piano. I played a lot of piano, and I'm getting rusty. But let's hope I can find time to keep that up, because I do enjoy it.
Yes.
But thanks for sharing.
Yep.
It's amazing.
Thank you for the invitation. I really appreciate it.
And so before we finish off, what other advice can you offer to young researchers starting out, other than all the wisdom you've shared so far?
Passion.
I
think that's ultimately what keeps us going. I mean, I think that there was a couple of points in my life, actually, when really there kind of was a decision between money or interest. And I thought then, I still think now, that I'd rather be poor and happy than rich and sad. And the secret to being happy is to work at the things that give you satisfaction. The moral of the story is that I had financial problems early on in life, but I'm fine now. We will be okay. I did what, in the end, the shift particularly to the university, for example, I took a salary cut. I took a large increase in work. And would I do it again? Absolutely.
Yeah, absolutely. And turns out you had to take it to find that passion in the end that really led you down the path, because otherwise you wouldn't have taken up the extra job working with the litter. So
absolutely
amazing advice. Yeah, I certainly agree. I think there's often this debate nowadays among generations as to whether it should be passion or not. But I think once you feel it, you know it.
With my kids, because I never tried to tell my kids what to do. They all got to university, and I just said, do the thing that you feel most passionate about. And they all seem very happy.
And that's the main thing.
And I think that's the way to go. None of them, by the way, are paid that much in their profession. So it definitely wasn't for money. But, money's not everything.
No, but the passion keeps you happy. And I think with that, you can do a lot more. So where can people find you if they want to get in touch?
Well, yes, I'm an Emeritus Professor at University of Cape Town. The nice thing about Emeritus Professors, it's a lifetime appointment. So I will remain officially part of their staff until I move to higher pastures.
Oh.
So, through the university page, they should be able to get hold of me quite easily.
Yeah, definitely. Are you on social media?
No, I never really took to social media at all. Just not my thing.
Maybe we'll get you started one day.
I doubt it.
But we'll definitely put this and everything we've discussed in the show notes so that listeners can read up on a lot of the topics, this broad diversity of topics that we've covered. But Neil, thank you so much for joining me today. And like I do with every guest on the show, I always give my guests the final word. So one final message, anything you want for the listeners to take away from today.
Oh, all these great words. Well, as I said, I already mentioned, do what you're passionate about. But I think also it's trying to make a difference. I think, to me, one of the greatest tragedies in life would be to have a career, and at the end of the day, you look back and you didn't see any major contribution that you made. And I think that, of course, is the lot of many people. Many people are not blessed to have a career where they can say that they changed something, although I suppose there's always something. But I do think that when you're working in a profession like urban drainage, you actually have the ability to leave a mark for at least a generation or two to follow. I sometimes used to tell my family about all the monuments that I'd left from my consulting days. I designed that pump station. I designed that reservoir or whatever it is. It's nice too the fact that as engineers we do leave our monuments. But I think ultimately it's the greatest satisfaction is to be able to look back and say, I made a difference.
Thank you very much. And that wraps up our entertaining, inspiring, and heartwarming episode with Neil Armitage. For more information on the infamous Canoe Chute on the Berg River, guidance on SuDS in South Africa, or any leads on where to hear Neil's great singing voice, check out the show notes for more information over at petermbach.com/podcast. And as always, thank you listeners for tuning into this episode and for your feedback and support. If you're enjoying this show, I would be incredibly grateful if you could share this podcast with your family, friends, colleagues, and even fellow canoeists. Please also do subscribe or follow this podcast on Spotify, Apple Music, or wherever you are listening from to be notified of the latest release as soon as it becomes available. If you're curious about me or my work in general, you can also check out my website or social media. Head to petermbach.com, my YouTube channel, Peter Marcus Bach, that's Marcus with a C, or follow me on X at Peter M. Bach or Instagram at petermbach87. Feel free to reach out to me with any feedback or guest suggestions so that I can keep improving this show, and follow the podcast's LinkedIn page to stay informed. The podcast's intro and outro song is called Starsky by Alex Kieran. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.